Hello and welcome. Today we're going to be discussing the process of factoring polynomials completely. Previously we've discussed different methods of factoring polynomials, factoring by grouping, factoring trinomials by the diamond method, and factoring differences of squares. Now we're going to start putting those methods together to factor polynomials completely. Step 1, anytime you are factoring, is to factor out the greatest common factor. Step 2, we factor the remaining polynomial. And step 3, we are going to ensure that each individual factor is prime. If not, we are going to factor them further until they are prime. For example, step 1, in this polynomial below, I am going to factor out the greatest common factor. I see a 2 in common between all four terms, so I factor out that 2, leaving me with x to the third plus 5x squared minus 9x minus 45. Now from here, I'm going to factor that polynomial inside by grouping. So looking at these four terms, I am going to split them down the middle. Look at the greatest common factor of the left, that is an x squared. Factoring that out, I have x plus 5. And on the right, I take out a negative 9 that's in common, so that that first term is positive, leaving me with a positive x plus 5. Don't forget this whole time that you do have a 2 on front of your polynomial. From here, I take out the x plus 5 that's in common. X plus 5 comes to the front, leaving me with x squared minus 9 in my second parentheses. And again, don't forget that you have a 2 on the front. Now, looking at each of these, we need to make sure that we cannot factor them down any further. This first factor of 2 is already prime. Looking at x plus 5, I am unable to factor that any further by either greatest common factor or one of our three methods. However, this last set of parentheses is the difference of squares. Since it is the difference of squares, we're going to go ahead and factor it further. And how we do this is we notice that x squared is a perfect square, so we write that as just x squared, minus 9 is a perfect square, so I write that as 3 squared. Since these are both perfect squares, to factor, all I do is take the bases of x and 3, I add them to get x plus 3, and subtract them to get x minus 3. So that factor of x squared minus 9 became this x plus 3, x minus 3. So in front, I still have the x plus 5 and the 2. So this is the final factored form of your polynomial. You cannot factor any of those pieces any further. I'm going to go ahead and do one more and then ask you to do the next two on your own. First thing I'm going to do is look for a common factor between all three terms. I see I can take out a 3, leaving me with x to the third plus x squared minus 16x minus 16. Now looking at that polynomial inside parentheses, I'm going to go ahead and split it in half since it already has four terms. I take out an x squared from the left, leaving me with x plus 1. From the right, I'm going to take out a negative 16 in order to make that first coefficient positive. So I have positive x. Dividing negative 16 by negative 16 leaves me with a positive 1. Don't forget you have that 3 on front still. Now I see an x plus 1 repeated. I factor out that x plus 1, leaving me with an x squared minus 16. And again, you still have that factor of 3 on the front. Looking at each of these factors, I see that x squared minus 16 is the difference of squares, so I'm going to go ahead and factor that down. X squared minus 16 becomes x plus 4 and x minus 4. And in front, I still have my x plus 1 and my factor of 3. So all I did here is I took that x squared minus 16 and split it up into its prime factors. Now looking at this polynomial, there is no further way to factor it since each of those factors are prime, so I am done. In the second problem below, I'm going to go ahead and change this 5 to a 15, just so that the problem works out correctly. Now please go ahead and pause the video and try these next two on your own. For the first, you should have factored out a 5, and then after factoring by grouping, you should have obtained 5 times x plus 2, x minus 2, times x plus 3. Thereafter, you should have factored out first a greatest common factor of 10, leaving you with x plus 2, x plus 3, and x minus 3 as your prime factors. Okay, now let's recall for a moment. Factoring the difference of squares. We're going to go into factoring the difference of squares from different forms. We've just seen something similar to this in the last slide, but let's go ahead and address this directly. This is the difference of squares because I can rewrite it as x squared minus 3 squared. And factoring, I take the bases, x and 3, add them, and subtract them. Since I cannot break either of these sets of parentheses down any farther, that is my final factored form. Now here again, this is the difference of squares because I may rewrite this as x squared minus 4 squared. To factor, I take the bases and add them and subtract them. Now looking at each of these factors, I see that neither of those parentheses may be factored down any farther, so this is my final factored form. Now, to factor each of the following, we are going to rewrite them as the difference of squares if possible. So we are going to proceed similarly to how we did above. However, you'll notice my exponent here is not a 2. That's okay. That doesn't mean we can't rewrite it as the difference of squares. I may take my x to the 4th and rewrite this as x squared to the 2nd power. So I'm kind of working backwards here. You should know that if you have an exponent raised to another exponent, you multiply those together to simplify. Well, now instead, I'm undoing it, and I'm saying x to the 4th can be written as x squared to the 2nd power, and 25 may be written as 5 to the 2nd power. Now I look at my bases. My first base is x squared, my second base is a 5. I take those two bases and add them to get x squared plus 5, and subtract them to get x squared minus 5. Now looking at each of these factors, neither may be factored down any further, so we stop here. Similarly down to the left, I see that x to the 6th may be written as x to the 3rd, all to the 2nd power, while 9 can be rewritten as 3 to the 2nd power. So these are the difference of squares. Looking at my bases, on the left I have x to the 3rd, and the right I have a 3. I'm going to take those two bases and add them to get x to the 3rd plus 3, and subtract them to get x to the 3rd minus 3. I cannot factor these down any further. I may not factor by grouping, nor may I use my diamond method or the difference of squares on either of those parentheses, so I am done. To the right, I see that x to the 8th can be written as x to the 4th raised to the 2nd power, and 36 can be written as 6 to the 2nd power. Because they can both be written with exponents of 2, this is the difference of squares. I take my bases, x to the 4th and 6, and I add them to get x to the 4th plus 6, and subtract them to get x to the 4th minus 6. Looking at each of these sets of parentheses, you do not have the difference of squares in either of them, nor may you factor by grouping or use the diamond method, so this is your final factored form. Go ahead and take a moment to try the top 4 on your own. On the top left, you should have had bases of y to the 3rd and 7. On the top right, you should have had bases of y to the 5th and 5. Down to the bottom left, you had two variables. Your first base should have been x to the 3rd, and the second base should have been y to the 2nd. And last, on the bottom right, this first term had a coefficient of 25, which is a perfect square. So your base should have been 5 from the 25, and x squared as base of your x to the 4th. Your second base should have been a positive 4. Now down below, we're going to add on to this concept just a little bit. Remember, when you are factoring, you must be sure that every factor is prime. If not, you factor further. So here on the left, I see that x to the fourth can be rewritten as x to the second raised to the second power, while 16 can be written as 4 to the second power. So now I see I have the difference of squares, and I factor by taking my bases of x squared and 4 and adding them and subtracting them. Now before I move on, assuming that I'm done, I'm going to go ahead and look at each of these individual factors to be sure that they both cannot be factored any further. On the left, this is not the difference of squares, so I cannot break it down any further. However, on the right, this is the difference of squares, and I may write it as x plus 2 times x minus 2. That factor of x squared plus 4 still remains on the front, and this is your final factored form. To the right, I see that my base of 16 is 4, and x to the fourth can be written as x squared. So my base is 4x squared, and 1 can be written as 1 to the second power. So I have factors of 4x squared plus 1 and 4x squared minus 1. Now looking at the first set of parentheses, you may not break this down any further because there is not a subtraction sign in the middle. However, here to the right, that is the difference of squares. I may rewrite that as the factors of 2x plus 1 and 2x minus 1. That factor of 4x squared plus 1 still remains on the front. And this is your final factored form. Below to the left, you may break this down as y to the fourth raised to the second power minus x squared raised to the second power. And factoring, you should have y to the fourth plus x squared times y to the fourth minus x squared. Now the first, since it is not subtraction, you may not factor as the difference of squares. However, the second on the right, you may break this down into y squared plus x and y squared minus x. That y to the fourth plus x squared still remains on the front. And this is your final factored form, as you may not break any of those pieces down any farther. And last, I have y to the 12th, which can be rewritten as y to the 6th to the second power, minus, since 16 is a perfect square, I may rewrite it as 4x to the 4th raised to the second power. I take my two bases of y to the 6th and 4x to the 4th, and I add them and subtract them. Now looking at each of these individual pieces, this is not the difference of squares, so I may not break it down. However, I may break down this farther. Y to the 6th may be rewritten as y to the 3rd raised to the second power, and 2x to the 4th may be rewritten as 2x squared raised to the second power. So my base of the first is y to the 3rd, and my base of the second is 2x squared. I add them, and I subtract them. On the front, I still have y to the 6th plus 4x to the 4th. Now looking at each of these factors, again, this is not the difference of squares, so you may not break it down. This is not the difference of squares, so you may not break it down. And this last piece looks like it might be. However, y to the 3rd is not a perfect square, so you may not factor that any further. Because all of these are prime, this is your final factored form. We'll go ahead and stop here for today. Thank you very much for watching. I hope you enjoy the rest of your day.